Hey, 8th grade. So in this last video, we're going to take a look at one more method for solving quadratic equations. And this is one that we did last year. This is called completing the square. And then in the second part of this video, we're going to take a look at systems of equations using some quadratic equations, which are called quadratic systems, and take a look at how to solve those. So for the first part, again, completing the square, this is a method, like I said, we did last year. And this method is best used whenever you have a quadratic equation that has an a value of 1, but that will not factor. Okay, so whenever your a value is 1 or negative 1, but the equation won't factor, you can use completing the square. I have an example here in the box that's outlined for you step by step how this process works. So as you can see, you've got the equation x squared minus 12x plus 5 equals 0, and x squared minus 12x plus 5, okay, will not factor because 5 is prime. The only factors of 5 are 1 and 5. Neither of those would add to get 12. Okay, so this would be a good example of when you can use completing the square because your a value there is 1, and solve this once you get pretty good at it a little bit quicker than quadratic formula. So what I'm going to do is I'm going to jump down to example 1 down at the bottom. I'm going to follow these same steps here to do completing the square on x squared minus 8x plus 36 equals 0. Okay, and if you need to look back at the one in the box here, feel free to do so. So for example 1, okay, we've got, again, this equation x squared minus 8x plus 36 equals 0. The one thing that's different about completing the square compared to your quadratic formula or your factoring methods is you actually want to put your constant term on the right side of the equation. Okay, so my first step to this is I'm going to subtract my 36 over to the right side of the equation, and I'm going to leave my x squared and my 8x on the left side. And then I'm going to leave a little bit of space. I'm going to write some blanks because to do completing the square, your goal is to basically make the left side a perfect square trinomial. And the way we do that is we take half of our b term. Our b term in this case is negative 8. So we're going to take half of negative 8, which is negative 4, and then we're going to square negative 4. Negative 4 squared would give us positive 16. Okay, so the right side has become x squared minus 8x, or excuse me, the left side has become x squared minus 8x plus 16, basically. Okay? What I've done now is I've made this left side here a perfect square trinomial, which I talked about in the factoring video. Okay, the first term is a perfect square, the last term is now a perfect square, the 16, and the middle term is twice the product of x and 4. Okay, the square roots of both of those is an 8x, and so that means this left side here factors like this. It factors into x minus 4 quantity squared. And that is going to be equal to negative 36 plus 16, which is negative 20. Okay, the reason I did that is because now that I have a quantity squared on the left side of my equation, I can take the square root of both sides, and without going through quadratic formula, I can very easily solve for x now. So now if I take the square root of the left side, that is simply going to cancel out my square term, so that's going to give me x minus 4. And then if I take the square root of the right side, that's going to give me plus or minus square root of negative 20. Okay, so now I'm going to simplify my radical. So I have plus or minus radical negative 20. That's going to be plus or minus. There's going to be an I definitely in that. Radical 20 can split up into radical 4 times radical 5. So you end up getting 2I radical 5 when you simplify this. Okay, and then you still got an x minus 4 on the left side. Your very last step is going to be to add 4 to both sides, and so you end up getting an answer of 4 plus or minus 2I radical 5. Okay, again, the key step to completing the square and the thing you need to know how to do is to go from this step here, the second step, to this third step right here, and how to do that factoring of a perfect square trinomial, and that's what we're going to practice again in number 2. So in number 2, I have x squared plus 6x equals negative 34. This time, my constant term is already on the right side, so that's good. That's where I want it. So I'm going to go ahead and I'm just going to draw in my blanks for this one. So I've got x squared plus 6x. I'll add in my blank over here equals negative 34 plus, and then add in my blank right there. And again, the goal of this is to turn the left side into a perfect square trinomial. So we're going to take half of our b term, which is 6. So half of 6 would be 3. We'll square it. 3 squared, we get 9. Okay? And then that 9 goes over here in this blank. So on the right side, I have negative 34 plus 9. That becomes negative 25. On the left side, again, you have x squared plus 6x plus 9, which factors into x plus 3 quantity squared. Okay? Basically what you're doing is you're taking this x and this 3, and they're coming down here to this binomial, is essentially what's happening. And so now you can take the square root of both sides, which is going to cancel out your 2 exponent on the left side. So now we're just going to get the quantity x plus 3 equals plus or minus radical negative 25. Well, we know that radical negative 25 is just equivalent to plus or minus 5i. And so now I can just subtract 3 from both sides. And I end up getting a solution of negative 3 plus or minus 5i for this one. Okay, so again, this is just an alternative to factoring and quadratic formula. You do have to know how to do this method, okay, for your upcoming test, but there will be some problems where I just say solve, and if you don't like this method, you can try a different one as well, okay, but there will be a couple that you will need to know how to do for your Unit 3B test. Now let's look at the back side and do the second half of the video, which is quadratic systems. And if you remember when we did systems of equations, okay, we always did 2 equations that were lines, and every time you solved a system of equations with 2 lines, you always found the intersection point, okay? That's what the solution of a system of equations is. It is the intersection point of 2 graphs. Well, if you have a system of 2 quadratic equations, or 1 quadratic and 1 linear equation, you could have more than 1 intersection point. So you can see from these examples of these graphs here that anytime we're doing a system of quadratic equations, okay, we could have 2 solutions, 1 solution, or no solutions. So if you look at the far left here, I've got an example of 2 different types of graphs that would give you 2 solutions. Okay, up here at the top we have a parabola that's intersecting a line, okay, and you're intersecting at 2 different points. Okay, right here is the intersection point, and then right here is another one. So that system right there would have 2 solutions. Same thing if you have 2 parabolas. They could intersect at 2 different points in this example here. Okay. You can also have a system that only has 1 solution. If you look at this graph right here, this flat line and this parabola, they intersect at the parabola's vertex, so that's only a 1 solution system. And the same thing with these 2 parabolas here. They have the same vertex, and so that would be a 1 solution system. And of course, you can have no solution. Okay, you can have a parabola and a line that never intersect. Okay, like in this graph here, there is no intersection point, and there never will be. And same thing with these 2 parabolas here. Those 2 will never intersect, and so those would be examples of no solutions. So when we're solving a system of quadratic equations, we're basically finding the number of intersection points and what the coordinates of those intersection points are, and these are the different scenarios you could get. Okay, 2 solutions, 1 solution, or no solution. And we're going to solve all of our systems here in the next 3 examples using the substitution method. So if you take a look at example 3 here, we have the quadratic equation, y equals negative x squared minus x plus 6, and then we have y equals x plus 3, which is a linear equation. Okay? Well, since they're both y equals, okay, what we can do is we can very easily do substitution on this. Since we know y is equal to x plus 3 on the bottom, we can plug in the quantity x plus 3 for y on the top equation, and we get this. X plus 3 equals negative x squared minus x plus 6. And now basically we've combined these 2 equations into one, and it's now a quadratic equation, and this is what we've been doing this entire unit. So we're going to be solving this quadratic equation now using whatever method we choose by setting this equal to 0. Okay, so I'm going to get everything on the left side of the equation so that I make my square term positive. So I'm going to add x squared to both sides, add x to both sides, and subtract 6. So that's going to give me x squared plus 2x minus 3 equals 0. And now I can solve this equation here using some factoring. Okay, this equation will pretty easily factor. You need factors of 1 and 3 that will have a difference of 2. Well, that would be -1 and +3. Okay, so that's how we factor that equation, and that means we have two solutions at -3 and -1. Okay, those, however, are the x value solutions. Okay, those are the x value solutions of my system here. Now I need to take both of these x value solutions and I need to plug them back in to one of my original equations up here to find their corresponding y value solutions. Okay, so what I'm going to do is I'm going to take my bottom equation, y equals x plus 3, and I'm going to substitute my x value of -3 into that bottom equation. So that tells me that when x is equal to -3, y is equal to 0. So I know one of my intersection points for this system is the point -3, 0. Okay, now I'm going to do the same thing for my other x value I found. X equals -1. And I'm going to find the point there. So I plug in a -1 for x. And y comes out to be +2. Okay, so this is basically just how we solve systems in the last unit 2. Okay, but now we're getting two x values for some of our problems, so we're going to get two different ordered pairs. -3, 0 is one of our ordered pairs, and then -1, 2 is our other ordered pair. Okay, moving on to example 4. We have y equals 2x squared minus 5x plus 6, and we have y equals 3x minus 2. Okay, so the same thing, I'm going to do substitution on these. I've got a quadratic and a linear. I can plug this 3x minus 2 quantity in for y up into my top equation, and so I get this. 3x minus 2 is equal to 2x squared minus 5x plus 6. So I'll go ahead and I'll set this equation equal to 0. So you get 2x squared minus 8x plus 8. And then we can do some factoring. I can factor out a GCF of 2. So I get x squared minus 4x plus 4. And then I can further solve this by factoring x squared minus 4x plus 4. Okay, I can also divide both sides by 2. That 2 is really not going to matter. So to factor x squared minus 4x plus 4, you can either think of two factors of 4 that combine to get 4. That would be 2 and 2. Or you could recognize that's a perfect square trinomial. X squared minus 4x plus 4 would just factor into x minus 2 quantity squared. Okay. So either way, you solve that, you factor that, you solve, you get an x value of 2. And so now we need to take that x value of 2, we need to plug it back into one of our original equations. I'm going to choose the bottom one, y equals 3x minus 2, and we need to find what the corresponding y value is. So again, every time for these you solve for x, you have to go back, plug that x value in for y, and that tells you what the intersection point is, what the ordered pair is. So now I'm going to have y equals 3 times 2 minus 2, which gives me 6 minus 2, which means y is equal to 4. So I only have one intersection point for these two graphs here. That intersection point is at 2, 4. Okay, and then finally for number 5, we have y equals negative x squared minus x plus 12 and y equals x squared plus 7x plus 12. Let's go ahead and solve those. Okay, same thing I've done for the last 2 problems. I'm going to go ahead and use substitution. So I know that this quantity, x squared plus 7x plus 12, I can plug in for y up here. And if I move everything over to the left side, I would be adding x squared, adding x, and subtracting 12. That's going to give me this, 2x squared plus 8x. My 12's cancel, so I get equals 0. So I have a binomial on the left side. So now you can factor that binomial by factoring out your GCF, which in this case is a 2x. So I factor out a 2x, I'm left over with x plus 4. And so that means your x values are going to be x equals 0 and x equals negative 4. Okay, so now I'm going to take those 2 x values, plug them in back to one of my original equations to find their corresponding y values. Okay, so I'm going to start with x equals 0. This time, both of my equations to begin with were quadratic, so I'm going to go ahead and take the second one down there. Again, it really doesn't matter which of the 2 you pick to plug back in to find y. So I'm going to plug x equals 0 into this bottom equation of y equals x squared plus 7x plus 12. 0 is not too bad to plug in. So you get 0 squared plus 7 times 0 plus 12, which just means y is equal to 12. Okay, so we have the ordered pair 0, 12 is one of our solutions. And then the other solution, we're going to plug in x equals negative 4. So we end up getting y equals negative 4 squared plus 7 times negative 4 plus 12. That gives us 16 minus 28 plus 12. Okay, and 16 minus 28 gives me negative 12 plus 12. I end up getting a 0 for that one. So my second ordered pair comes out to be negative 4, 0. Okay, for the systems of quadratic equations, there is a way to check these on your graphing calculator. So if you go to your graphing calculator, and we're just going to check this last one real quick. If I graph both of those equations on my calculator, so my first equation was y equals negative x squared minus x plus 12. And your other equation was y equals x squared plus 7x plus 12. Okay, you can go ahead and you can find the 2 intersection points. Let me zoom out for a second here. Using your Analyze Graph feature. Okay, so if I go to Menu, 6, 4, okay, I can find my intersection points. My first one's going to be over here, again at negative 4, 0, which is one of the solutions that we got. Okay, and then your second one should be, if we did it right, at 0, 12. So go back to Menu, 6, 4, and you can see the second one's up here on the y-axis at 0, 12. Okay, so again, that's basically what we're doing. We're algebraically using what we know about solving quadratics, finding where those 2 different graphs intersect, either 2 different parabolas or a parabola and a line each time. Okay, as always, feel free to rewatch any part of the video that you need to. Go ahead and email me some questions, so that way when I see you guys again on Tuesday, I can answer those, any that you had over these notes. Okay, and continue working on that study guide as you prepare for your test coming up on Thursday. Have a nice day. You're all wonderful people, and I will see you on Tuesday.